Hello everyone, welcome to this video on singly linked list. Today we will focus on traversing a singly linked list and printing each node's data. So traversal is the fundamental operation that helps in accessing and processing the elements which are stored in the list. So we have a recap of a structure. That is, a singly linked list consists of node where each node contains a data and a pointer to the next node. The list starts with the head node and ends with the node pointing to null. So understanding this structure is crucial for efficient travel in a singly linked list. So what is a traversal? Traversal in a singly linked list, it involves visiting each node starting from the head node and following the pointers until we reach the end of the list. That is, first we have to start at the head. That means we have to begin the traversal from the head node, which is the starting node. Next we have to access the data. That means we have to print or process the data which is stored in the current node. Next is we have to move to the next node. So for moving to the next node, we have to follow the pointer to the next node. And next is the repeat operation. That means these set of operations should be continue this process until we reach a node with the null pointer, which indicates that is the end of the list. So this loop will ensure that every node in the list is accessed and the data in present in that node is get printed. So here is an algorithm which I was explained is the same. So first of all, for printing each node data, we have to create a pointer called temp and we have to assign that pointer to the head node's address. So after that we have to print the data which is present in the temporary node. So after printing the data, we have to move that temp pointer to the next node. So we have to continue this until we reach the null pointer. So look at this example. So here it's here it is temp points to the head node, right? So here the temporary pointer is at the node 10. So the data which is present on the temporary node is 10. So it will print 10. So next we have to move the temp pointer to the next node. So next node is 2024. That is the address stored in the first node. So we are moving that temp pointer to 2024. So the 2024 is now the current temporary node. So the data present on that current temporary node is 20. So here we are checking that temporary node is not null. So sure, if it is not null means it contains the data. So here the data is 20. So the 20 is get printed. So after printing 20, we are moving that temporary node to the next node which is of 3024 address. So again here we have to check whether the temporary data is null or not. So again here the temp data is not null. So we in the address 3024 the data present is 30. So we will be presenting or it will print the data 30. So after that we have to move to the next pointer, but there is no pointer to move ahead because the last node address pointer is defined as null. So which means that we had reached the end of the list. So we have to stop process and we have to print the whole linked list. So this is how you have to traverse on a singly linked. This is how we have to traverse on a singly linked list, and we have to print the data on the singly linked list. So this is the operation for traversing a singly linked list. So it is a straightforward approach, but it is an essential operation that allows us to access and manipulate the data within the list. So by understanding this process, you can able to perform a variety of tasks on a list such as searching, sorting and modifying the content of the list. So thank you for watching, and I hope this video helps you to understand how to traverse and print each node in a singly linked list. Thank you. So here I had given some of the reference of the textbook, you can refer it for clearly understanding the concepts of data structure. So thank you.